So number 5 asks you to sketch out all of the circuits that you've drawn. So we have to learn some of the conventions because you don't draw a circuit like we would just sketch something in art. There are actually rules and there are symbols for everything that every electrical diagram shares. So let's go through those quickly. First thing is, whenever we're drawing a wire between two things, we try and keep those as straight lines. We don't want them wavy lines going all over. It makes it very hard to follow and to understand. Whenever we get to a corner, we're going to try and do it at a right angle whenever possible. In general, a lot of our circuits will look like squares or boxes. Here are a few common symbols. Instead of drawing a battery out, we get the battery with 2 lines. So a long line usually is on the top, a short line is on the bottom. The long line is the positive and the short line is the negative, and it looks like a minus sign. Light bulb, instead of drawing the actual bulb, there are a couple different ways to do it. One of those ways is a circle with a big X in it. The lines coming out of the top and bottom of each of these are the wires that we connect. So they continue one way or the other. They can be rotated if you want, although very often something like a battery or a voltage source goes over on the left, so it will be going up and down. But these certainly, you could have it on the right, which might be up and down or going side to side across the top. We have got something called a resistor, which we're going to use in future labs. A resistor is just a device that its purpose is to resist the flow. And that allows us to change voltages in different parts of the circuits. It could be used as a heater. So the 3D printers, I actually have this one taken apart. The 3D printers have to get very hot to melt the plastic. This piece right here is actually just a resistor. And the whole point is to, as electrons go through something, they bump into the atoms that are there, and they make them warmer. Well, this is intended to make it very, very hot. So use that change of energy for a purpose. The exact number of saw teeth there doesn't really matter. It's a squiggly line like that. We've got an ammeter that would measure current. That you would put an A in a circle. And then yesterday we were using voltmeters. That's a V in a circle. So each of those indicate that you want to measure something, either current with an ammeter or voltage with a voltmeter. And then finally, we don't end up using this too much, but we'll put it on there since it's on the page, a switch. A switch looks like a piece of wire that's broken and part of it's folded up, because this would be an open switch, so electricity couldn't flow. When you closed it in, then it would connect the 2 wires and you'd have electricity flowing. Okay, so let's do one of these or 2 of these together, like you'll want to do in your lab. Number 5 in your lab asks you to draw the circuit diagrams for each of the circuits using the appropriate symbols that we just saw for the batteries and bulbs lab, the lab that you just did, the series circuits 1. You'll need 3 to 4 lines, so you've got to spread these out. So let's start with our first circuit, 1 battery, 1 bulb. This is going to have a generally square shape, each of these. And usually I start on the left, and that's where we'll put our voltage source. which is a battery. So there's our battery. We're going to have the wires coming up out of it. With the battery, like the diagram part showed, we always also record the voltage. So whatever voltage you measured for this, you'll put right next to it. So maybe that was 1.21 volts. But every voltage source should get that. Then we've got just a single bulb. I know this is going to look essentially like a square. It doesn't really matter what side of the square I put the bulb on, although I wouldn't typically put it right next to my battery. So I might put it on the top or the side, and either place is fine. There's a bulb, and I connect the rest of it with lines. And that's my circuit. The one additional thing that it asks is include 1 voltmeter in each diagram connected to measure the voltage across one component, a battery or a bulb or any of it. Voltmeters, just like when you were using it, you'd have the circuit built and then you'd come in with the voltmeter to connect it. We're going to do the same thing. So we'll have, let's measure it across the battery. We have a voltmeter here, and then the wires just come out, and often we put a little dot where they meet up to show that they are actually there. And that indicates a voltmeter that's set up to measure the voltage drop across that battery. If we wanted to do the next one with 2 bulbs, I don't want to squish the bulbs in here, but really the only thing I'd have to change is I'd probably put it on one of these 2 sides to spread it out a little bit so it doesn't get all mushed together and clustered. About the only change I'd have to make is that. So now it's a circuit with a battery. I'd update this if I needed to, the voltage. It's got 2 bulbs in it, and my voltmeter is measuring the voltage across that bulb. I could put a 3rd one up here. If I want to do more than 1 battery, so your next circuits have 2 or 3 batteries, we draw them next to each other. So a stack like that shows 2 batteries, and maybe that'd be 2.45 volts. And then we do the rest of the circuit. 3 batteries would have 3 pairs of these lines, but otherwise would be the same. Would be the same. So in this will make sure that you make these big enough so that they're easily legible, and otherwise just label the voltage just for the battery. We don't need voltage for everything, just the source, and put 1 voltmeter in for each one.